Good evening, all. Today we are going to talk about a new lecture, which is about the Kaldor-Hicks compensation criteria, or as well as it is popularly known as the Kaldor-Hicks efficiency criteria. How one could basically, have a sort of efficiency understanding if the first best is actually failed. So, or what is actually in an alternative discussion, normally people try to articulate that if the first best case of the Paretian kind is basically gives us that actually not many options. That is, it is not giving us not many options, because the options of different situations like A and B, or from A to B, is always gives or lead us to say that one person, if I get worse off, then moving from the state to A to B is non-rationalizable. So that means every given situation under the first best is normally treated as an efficient situation. Then it is actually pointless to move from one state to the other. So this is actually, in fact, makes a lot of trouble when it comes to the social welfare function or the analysis of social welfare function. Now, in that context, if there were generally agreed social welfare function, there would be no problem. That is, in principle, in ranking alternative allocation is only shifts from one ranking to the other. But in alternative reality, things are not actually as simple as we think. So one would simply compute the value taken by social welfare function for the allocation of interest and rank by the computed value, and allocation with the highest social welfare function would be ranked above one with the lower value. So this is also another kind of an issue which normally encounters, and there is not, however, an agreed social welfare function in that sense. So the relative weight to be assigned to the utilities of different individuals are an ethical matter in this case. But however, the ethical fairness issues we'll discuss in a different lecture. So this lecture is basically about the efficiency, and given that the first best efficiency criteria, popularly known as the Pareto efficiency, is under jeopardy, because if situation is Pareto efficient, then there is no room for say growth, development, or moving from one state to another, if actually the pie is given, or sort of it's a closed economy, etc. So there are many point it will bubble once you talk about all these things. So there are two problems principally with this criteria of efficiency, that is the social welfare function. uh, Precisely, the first one is, as we have seen, the recommendation that all reallocation satisfying this condition be undertaken does not fix a unique allocation of one kind. The second one is, considering policy issue, there will be very few proposed reallocation that do not involve some individual gaining and some losing. So only rarely be will the welfare economists be asked to advise about a reallocation that improves somebody's lot without damaging the other person. So most reallocation that requires analysis involved winners and losers, and are therefore outside of the terms of Pareto improvement guide. This is what is in the simplest sense I put up in the very beginning, that in the Paretian world, it is actually talks about a given situation, or you can say that it's a static situation where the stage A is said to be efficient, and because then otherwise, if you move from state A to B, then you have to strictly adhere to the principle that you shouldn't actually make a person worse off, and still you can actually improve. Now, even if you adhered to this principle, it says that the initial allocation is inefficient. So then you can't say that the initial allocation of parity and kind is actually is efficient. Therefore, that given situation was not efficient. So in that sense, if you are moving from that state to another state, then you are moving from an inefficient state to an efficient state. So the latter is actually the real efficient state, which normally under a static situation we need to consider. So this in fact pose a lot of undigestible kind of a logic, or kind of sometimes people think that what kind of thing which we welfare economists smokes out. So this kind of an issue always pops up. That is why the discussion of Kaldorian kind got its relevance, especially when in 1930s the discussion of efficiency was in picture. There are so many people, including Miss Robbins, talked about the impossibility of interpersonal comparison of utility, or in sense, it is also reflective of the fact that even interstate is incomparable in that sense. So that is, state A and B is different in that sense. So this is actually given all this discussion under a sort of spellboundness, or what you call, there is a stagnation in thinking process in that sense only. Kaldor in 1939, as a response to this sort of a discussion, he made a point that, so let's look into actually our movement or efficiency or growth or whatever, or change in the society, in this following sense, that if somebody gets a policy that is state B is actually gives a sort of a benefit to some people, and that benefit can be distributed to the people who lost through the process of redistribution, and still if some person is actually gains, then you can say that that policy is a better policy than the other. But this is actually a deviation from what has originally been Pareto conceptualized, or basically made. So in that context only, this Kaldor compensation test makes its own sense. That is, welfare economists have tried to devise compensation tests which do not require the use of a social welfare function of comparing allocations where there are winners and losers. Now, in this context, it is quite clear of the Kaldorian kind, which I was just mentioned. That means a policy change is definitely going to create a kind of a winner loser in the post process. But in the Paretian sense, that is not advisable, because some people getting loose means efficiency of that particular reallocation is not necessarily advisable. So this is what was actually social welfare function, or social welfare economists in fact had a trouble at that point of time. So suppose there are two allocations, denotes 1 and 2, to be compared. I'll come with that of a numerical example to make it clear. And in that numerical example, we have two states, that is 1 and 2. We will compare that to state, and then we see that moving from allocation 1 to 2 involves one individual gaining and the other losing. Similarly, the Kaldor compensation test says that allocation 2 is superior to allocation 1 from the given table, which I'll shortly show you. That is in the 4.1 table. This is an interesting table, which is also continuation of what we have done earlier. So of the welfare economics. So in this particular one, 4.1 table, that is we have a set of three table I would like to show. And in the first table provides an illustration of the situation where Kaldor test has 2 superior to 1, and in this constructed example both individual have utility function, that is u is equal to xy, and a is the winner for the move of 1 to 2, that is the state 1 to 2, while b loses from such a move in that context. So according to the Kaldor test, 2 is superior because at 2 A could restore B to the level utility that she enjoyed or he enjoyed at the first instance after a little bit redistribution. Now, this test does not require that the winner actually does compensate the loser. It requires only that the winner could compensate the loser and still be better off in that sense. For this reason, the Kaldor test and the other to be discussed below are sometimes referred to as a potential compensation test in that sense. That is, you can say that you basically happens to have a situation of an Paretian improvement case, which we had earlier critically mentioned. However, it is not one and the same in that sense. And if the loser was actually fully compensated by the winner and the winner was still better off, then there would be a Pareto improvement. But in the Paretian case, it is not actually allowed that somebody gets worse off in that sense. So this is actually an advancement over the previous one. So now look at the table 4.1. In the 4.1 provides a numerical illustration, as I said. See, look at the allocation. You have an allocation 1 and allocation 2 of xy, and there is a utility for both A and B. Now, in the initial allocation, the total utility is actually 50 for A and 100 for B, and the constituent component is already given. And in the allocation second, the constituent component is also given that the utility of A increases from 50 to 100 and 100 to 50. Now, if you ask, that is in this example, both individual have utility function that is already given, and according to the Kaldor test, 2 is superior because at 2, A could restore B to the level of utility that she enjoyed at a 1 and still make a better one, because x has actually changed to 20, and then still you can actually have a possibility in that context. Like starting from allocation 2, suppose that 5 units of x were shifted from A to B. This would increase B's utility to 100 in that sense, and reduce A's utility to 75 in that context. Now look at that, and if you say in that context, then definitely you have actually a case in second, that is allocation 2 better than allocation 1. Hence the allocation 2 must be superior to 1, as if such a reallocation were undertaken, the benefit and assessed by the winner would exceed the loser as assessed by the loser themselves. Now, a problem with the Kaldor test in that particular understanding is the following. Like the number that is in 4.1 have been constructed to illustrate a problem of the Kaldor test, and it may sanction a move from one allocation to another, but it may also sanction a move from a new allocation back to the original allocation. The problem is that if we use the Kaldor test to ask whether 2 is superior to 1, we may get a yes, and we may get also a guess a yes if we ask if whether 1 is actually superior to 2. Starting from 2 and considering a move to 1, B is actually winner and A is the loser in that context. So there is actually a kind of a reversal case. So this is one of the problem with the Kaldor understanding. So let me stop here, and we will move to the Higgsian understanding in the next next slide or next lecture.